Welcome back, everyone. Today, we're diving into a genuinely thrilling explainer covering the massive leap from reactive chat models to proactive, autonomous AI agents. We are focusing specifically on Chapter 12 of our core material, titled From Workflows to Autonomous Agents. Now, we spent a lot of time recently exploring model architectures, dissecting large language models, and fine-tuning performance, but honestly, up until this point, our interactions with AI have fundamentally been a two-way street of prompt and response. We've all had that moment, right? Where an AI gives us a truly brilliant, perfectly structured plan for a complex project or a family vacation, but then it just stops. It leaves us to do absolutely all the manual clicking, the booking, the data entry, the endless copy-pasting ourselves. It's incredibly smart, but entirely isolated. Well, today, that changes. We are going to examine exactly what happens when we liberate these systems from the constraints of the chat window and give them the programmatic ability to interact with the real world on their own.
Here is our agenda for today. First, moving beyond reactive AI. Second, defining the agent. Third, how agents solve problems. Fourth, the evolution of workflows. And finally, number 5, the agentic workflow.
Section 1. Beyond reactive AI. To appreciate exactly where this technology is heading, we first need to deeply understand the friction in our current software ecosystem. Right now, our amazing generative AI tools are essentially brilliant minds trapped in digital jars. They possess staggering computational power, vast troves of training data, and immense contextual understanding, yet their interactions are strictly confined to chat interfaces or single-turn API calls. Just think about the mechanics of this for a second. You provide a prompt, and the model spins up its massive neural network to generate a text response, or perhaps it applies a single descriptive label to a piece of data. And then, it stops completely. It just goes dormant. All of that incredible reasoning capability sits idle, waiting for a human to give it another command. This is fundamentally a reactive posture. It is a one-to-one exchange where you, the human, carry the entire cognitive load of stringing tasks together. Current AI completely lacks the agency to initiate actions, trigger continuous reasoning loops, or dynamically interact with the ever-changing digital world outside of its fixed internal knowledge base.
The disruption here is absolutely profound. Let's look at a practical example. If you ask a traditional chat-based model, what are the best vegan restaurants in my area, it acts perfectly as a static expert answering a trivia question. It parses your intent, searches its weights or a static index, and spits out a list of names. That is a single reactive turn of conversation. You now have to take that list, open your web browser, navigate to a booking site, figure out if they have patio seating, check the weather for that specific evening, and finally make a reservation. Talk about friction. But an AI agent operates as an autonomous digital assistant. You give it the high-level goal. Find a highly rated vegan restaurant with a patio that's open this Saturday and make a reservation for 2. The agent actually breaks this down. It goes out into the digital world, it queries a mapping service for local spots, pings a weather API to ensure Saturday evening is clear for patio seating, navigates the reservation software's backend, makes small sequential decisions based on the live data it gathers, and finally books the reservation for you. It fundamentally moves from simply thinking about a problem to actually executing the solution.
Section 2. Defining the AI agent. So how do we formally define this shift? The definition is crucial for understanding the underlying mechanics. An agent transforms a passive model into an active problem solver by independently figuring out how to accomplish a high-level task. In this architecture, the large language model essentially acts as the brain or the core reasoning engine of the whole operation. But as we know, a brain needs hands and eyes to interact with the world, right? For an AI agent, its hands and eyes are its integrations with external tools, scripts, and APIs. You no longer have to program the exact rigid sequence of if-then statements for it to follow. Instead, you just provide the final destination, the goal. The agent then creates a plan, charts the course, and begins executing. Crucially, while standard AI relies on human prompting to advance from step A to step B, an autonomous agent actually prompts itself. It takes the output from its first action, feeds that back into its own context window, and uses that new information to generate its very own next prompt. It's a self-sustaining loop of observation and action, adapting as necessary to reach that specific goal without a human ever pressing enter again.
Section 3. How agents solve problems.
Let's look under the hood. Every agent operates in a continuous, dynamic three-step loop, often referred to in engineering as a reasoning and acting framework. First up is planning. When given a complex goal, the agent's LLM brain decomposes that overarching objective into smaller, actionable microsteps. Going back to our restaurant example, it internally generates a plan. Step 1, search for vegan places. Step 2, filter by patio availability. Step 3, check reservation availability. Second is tool use. This is where the magic really happens. The agent reaches outside its internal knowledge and utilizes external software tools by generating the specific code or JSON payloads required to communicate with external APIs. It might use a search engine API to find the restaurants, a calendar API to verify the date, and a booking systems API to secure the table. Finally, and most importantly, we have reasoning. This is where we see true autonomy. The agent analyzes the live results returning from the tools it just used. So what happens if the booking tool API crashes or returns an error saying the restaurant is fully booked for a private event? A traditional script would simply fail, throw an error code to a human developer and give up. But an agent uses the reasoning phase to evaluate that failure. It reads the error message, updates its internal context window with this new reality, and dynamically adapts. It reasons, okay, option A is fully booked. I need to pivot, go back to step 1 of my plan, select the second highest rated restaurants on my list, and try the booking tool again. It is exactly this continuous self-correcting feedback loop of planning, acting, and reasoning that allows an agent to mimic human problem solving and ensure the ultimate goal is successfully met despite real-world obstacles.
Section 4. The evolution of workflows.
To truly understand why autonomous agents are a revolutionary leap in software architecture, we have to look at how we've historically structured business processes and digital workflows. Take a look at this table. Notice the column labeled determinism. This is the ultimate separator and a massive conceptual shift. In computer science, determinism has long been the holy grail. It means that given a specific input, a system will always produce the exact same predetermined output following the exact same predetermined path. As we move chronologically from traditional workflows on the top row to early AI workflows and finally down to agentic workflows, we are fundamentally moving away from strict, hard-coded predictability and fully embracing flexible, goal-driven adaptability. We're literally trading rigid determinism for dynamic problem solving.
Let's break this down further. Traditional workflows are the status quo that run most of the world's back-end systems today. They follow fixed, predefined, rigid logic. Think of extract, transform, load, or ETL data pipelines, or a basic Python script that automatically sorts and files incoming invoices based on specific email subject lines. They are completely deterministic. And hey, this is fantastic for predictable, highly repetitive tasks where the environment never, ever changes. But it is terribly fragile when dealing with the unexpected real world. For example, let's say a traditional script is explicitly programmed to read dates formatted as month, day, year. Suddenly, an international client submits an invoice formatted as day, month, year. What happens? The entire software conveyor belt simply grinds to a halt. It throws an exception. It completely lacks any adaptive capabilities and requires a human engineer to intervene, rewrite the rule, and restart the process from scratch.
Now, over the past few years, we began adding standard AI models into the mix to create what we call an AI workflow. But as you can see here, the underlying process fundamentally remains a rigid, linear pipeline. We are just applying smarter AI tools in a predetermined order. A great example, detailed in Chapter 12, is using an AI model to route customer support tickets based on sentiment analysis. The pipeline receives an email, passes it to the AI analyzes the text, assigns a sentiment score of angry or happy, and passes that score to the next step, which routes it to a manager or a standard queue. Now, the task itself is incredibly smart. Understanding human emotion is no small feat, but the routing structure is still entirely hard-coded and linear. The output of one step just rigidly serves as the input for the next. The AI only does exactly what we explicitly command it to do at its assigned station on the assembly line, meaning the overall workflow is still highly deterministic and cannot creatively deviate from its programming if something unusual occurs.
Section 5. The Agentic Workflow.
And that brings us to the ultimate paradigm shift in how software can operate, the agentic workflow. Agentic workflows introduce non-determinism. Instead of a linear, step-by-step sequence of hard-coded tasks, the AI is given a goal and the total flexibility to choose its own tools, adapt to real-time errors, and dynamically determine the absolute best path to success on its own. It's purely goal-oriented. A perfect example of this in action is an agent deployed to manage a complex travel itinerary. It doesn't just run a script at a set time. It proactively works in the background to book flights, hotels, and activities based on your broad preferences. But the real power is how it handles the unpredictable. If a flight is suddenly delayed by 3 hours due to a storm, a traditional script fails. An agentic workflow, however, parses that new delay data, autonomously recalculates the impact on the rest of the trip, uses its reasoning engine to determine a solution, and then seamlessly reaches out via APIs to push back the rental car pickup time and email the hotel desk about a late check-in.
It handles conflicting information and edge cases gracefully, without a human programmer ever needing to write an explicitly coded rule for that specific storm delay. The agent's choices dynamically vary based on the live situation it encounters.
This brings us to a crucial realization, perfectly captured in this quote straight from Chapter 12. Agentic workflows represent a leap beyond simple automation by empowering LLMs with genuine autonomy and agency. We are moving beyond simple automation into an era where AI can independently navigate unpredictable, multi-layered challenges. By continuously interacting with their digital surroundings, accessing real-time API information, and intelligently leveraging external tools, these agentic workflows introduce a level of operational resilience we just haven't seen before. Furthermore, because these systems utilize a reasoning loop, they can maintain a form of memory. They can actually reflect on their past failures, learn which tools work best in which scenarios, and refine their own problem-solving processes over time. They become increasingly efficient and capable without constant human intervention or software updates. It's a real game changer.
As we wrap up this explainer, let's briefly recap the journey we just took. We've explored how we are transitioning away from rigid, deterministic scripts that break at the slightest anomaly. We've moved past isolated chat models that rely entirely on constant human prompting to function. And we have finally arrived at the threshold of autonomous, reasoning agents capable of continuous, self-correcting action in the real world. We are literally standing at the edge of a massive operational shift in computing. So, I want to leave you with this final thought. When back-end systems officially transition from fixed workflows that require constant human maintenance and oversight to self-refining autonomous agents that dynamically adapt on the fly to accomplish complex business goals, how might that completely rewrite the rules, the efficiency, and the very structure of your industry? It's an absolutely fascinating future to prepare for. Thank you so much for joining me for this explainer, and keep exploring the incredible potential of autonomous agents.